Hey guys, welcome back to Helper Function. In this video, we will discuss a very popular interview question, best time to buy and sell stock. So the problem statement says that we have an array for which the ith element is the price of the given stock on day I. Now we are permitted to complete at most one transaction, that is, buy one and sell one share of stock, design an algorithm to find the maximum profit. And also it is given that we cannot sell a stock before we buy one. So if we buy a stock on day I and sell it on day J, then I must be lesser than J. And thus the profit that we will make will be price of J minus price of I. Let's try and understand with an example. Now the given array shows the price of stocks for 6 days. Let's say we buy a stock on day 2 and sell this on day 5. Thus the profit that we will make is 5. That is price on the selling day minus price on the buying day. Also, this is the maximum profit that we can get from this array. So let's see how to solve this. Now the brute force approach to solve this problem would be, assume we buy a stock on day I. Now we go through all the next days and compare the maximum profit. Let's say we are at 7. Then I will go through all the next elements, the next days. Thus my maximum profit would be max of max profit and price of J minus price of I. But this approach requires two for loop, making its time complexity order of n square. Now another approach would be, we can pre-compute the maximum from n minus 1 to I in an array. So let's say we have a max up to array whose ith index denote the maximum number from ith index to n minus 1th index. Now to create this max up to array is pretty simple. If price of I is greater than max up to I plus 1, then we will update max up to I as price of I. Otherwise, max up to I will be max up to I plus 1. Hence we have filled this max up to array from the right side. And now for every index, my answer would be max of answer and max up to I plus 1 minus price of I, where max up to I plus 1 represents the maximum selling price that we can get in coming days, and price of I represents the cost of buying the stock on this day. Now here the time complexity is reduced to order of n, but the space complexity here is also order of n, as we are using an additional array to store the maximum. We have another approach which can solve this problem in linear time complexity without using any extra space. So let's see that. So here what we will do is, we keep the track of minimum number till now. And now assuming that we sell this stock on day I, the profit which we will make would be price of I minus minimum. And thus we will keep updating our answer in order to get the maximum profit. Let's go through this example. As being on index I means that we are selling our stock on this day, we will start with index 1, as we need to buy a stock first in order to sell it. Thus initially minimum is 7 and answer is 0. Now every time we will be performing these two operations, first we update our answer and then we update the minimum. So for index 1, price of I minus minimum becomes minus 6, which is lesser than 0, thus my answer remains 0. But because 1 is smaller than 7, my minimum becomes 1. Now this time price of I is 5, thus price of I minus minimum becomes 4. And because it is greater than 0, my answer will become 4. This means that if I sell my stock on day 3, then the maximum profit that I can get is 4. And now because 5 is greater than 1, my minimum remains 1. In the next step, price of I minus minimum will be 2. And because it is lesser than answer, it will have no effect on answer. And also because it is greater than 1, my minimum remains unchanged. Now in the next step, price of I minus minimum will become 5, which means that if I sell my stock on this day, I will get a profit of 5. Thus my answer will be updated to 5 and minimum will remain 1. And at last, price of I minus minimum will be 3, which is lesser than answer. Thus it will have no effect. And finally we will return 5 as our answer. Thus, we were able to solve this problem in linear time complexity and without using any extra space. Now let's quickly look at the code. We are given with the price vector. N represents the size of this vector. Now if n is lesser than equals to 1, we will immediately return 0. As if we have only one day, we can never make a profit. Now min is the integer that will store the minimum that we have got till now. And max profit is going to be our answer, which is initialized to 0 at present. Now the for loop starts from index 1. First we update our maximum profit that we can get by selling our stock on this day. Thus right now my minimum is from index 0 to I minus 1. And after updating the max profit, we will update our minimum. And finally, after ending this loop, we will return max profit as our answer. So this was all about the problem. I put the problem link in the description so you can go and solve it. Also, if you have any doubts or suggestion, please write in the comment. Thank you for watching.